Hello, and welcome to the Thinking Elixir podcast, where we cover the news of the community and learn from each other. My name is Mark Erickson.
And I'm David Bernheisel.
Let's jump into the news. First up, notice that there had been a couple Elixir releases, these are point releases, that we hadn't talked about or hadn't called out. There's Elixir 1.18.2 and previously 1.18.1 were released. So I just wanted to identify a few of the changes in here as they might be relevant for you. And particularly, there's bug fixes, so you probably just want to update anyway, because there's some good stuff in here. One of the big ones that really jumped out to me in Elixir 1.18.2 was under regex. It says, ensure compatibility with Erlang OTP 28 and forward new regex engine. So I didn't know there was a new regex engine in OTP 28.
Oh boy.
So OTP 27 is the current release right now. We'll come back to that. But I remember when JSON was brought in officially as part of OTP, apparently regex has already been there. I haven't actually thought about where the Elixir regex code is coming from, if that's completely Erlang based or completely Elixir, I don't know. So it's just interesting, right? Like, there's more stuff is happening the Erlang side, and we want to make sure we're compatible with it. So a couple other things I just want to call out that are enhancements or bug fixes. So one is provide more AST context when invoking certain functions with trailing fragments. So that's just improvement on the AST that we're able to get, which is going to be better for code tools, right? So not going to directly impact you as a regular user. But bug fixes, in the CLI, there was one to temporarily remove PowerShell scripts for Elixir or Elixir C and Mix on Windows as they leave the shell broken after quitting Erlang. So if you have encountered that,
whoops,
you certainly want to just upgrade to get that fixed so it's not going to cause any temporary issues while they get it worked out. Then under XUnit, fix a crash when diffing bit string specifiers. There's other crash fixes under IEX autocomplete. And another one that was interesting was mixdeps update. Ensure Git dependencies can be upgraded by doing so against the origin. So it's like sounds like a check ahead, like maybe make sure we can do it if it's a Git dependency.
Yeah, because the mix lock does track the commit at that moment. So I guess it's just checking to see if there's a different commit, I reckon.
Yeah. Then under 1.18.1, there's a few things. Most of them are bug fixes, right? So this is like, why would I not want this, right? This is like, do not crash when typing violation is detected on dynamic dispatch. So this has to do with some of those new typing features that are coming to 1.18. And a lot of these are bug fixes around edge cases. But still, those are things that would possibly impact you in your application. So there's a few more. We got links to the changelog where you can check out and see more about it. Glad for the releases and that we could look in a little bit deeper and see, yes, it's good to upgrade. These are good. They look totally safe.
Of course. Yeah. Bug fixes.
Yes.
In the news, bug fixes fixed bugs. I did find the release note from the OTP RC that what the regex thing is about. So yeah, there's a new engine about that. So what that means is that the module RE, which is the Erlang regex app in there, it was updated to use PCRE2, which is mostly backward compatible with PCRE. The most noticeable incompatibilities are two things. The default character encoding is pure ASCII and not Latin 1.
Interesting.
So there's a couple of characters in there that is the difference between ASCII and Latin 1. So just heads up there. And then Unicode support is still available with the options of Unicode and UCP. I can't remember, but I want to say that the Elixir regex module is always Unicode aware, but I could be wrong there. So double check there. And then the item number 2 is that the options BSR _ any CRLF, something to do with line feeds and carriage returns there. And then another one, BSR Unicode and new line, options. So other options, there's a couple of options in there all about new lines, it looks like, are only set when a regex is compiled and cannot be changed at matching for pre-compiled regex. So there you go. If you're doing heavy regexing, looks like OTP 28 is going to be something that you want to double check on because they upgraded to PCRE2, which is all generally good news. No surprises there. I think most things are PCRE2 nowadays. So just playing a little catch up. But since I'm talking about OTP 28, there's one more thing in OTP 28 RC1 that's kind of new. I actually tweeted something incorrect about this, so I had to delete it and correct myself. but starting with OTP 28 RC1, a source software bill of materials, so shortened to SBOM, will describe the release on the GitHub releases page. So they're welcoming any feedback about that. This ties into that open chain certification that was announced by the EEF just a couple of weeks ago. Good news there. That's usually one of those compliance check marks that you got to have when using any sort of software. And so if anyone wants to use Erlang at all, Erlang needs to support this kind of stuff. And now they do. And then we had already talked about Elixir also opting into this. So that's coming up as well. That's already in main, I believe, on Elixir. So we'll see that on 1.19 when that comes out.
Very cool.
All right. Well, hey, outside of that, the next news item is that there's an experimental SQL sigil for Ecto being developed. Now, I normally don't talk about this. I just find it really interesting. It's really early, so don't go diving into this library and start using it. Not quite yet. I don't think it's there. And I would bet the author agrees. So just a heads up, right? We got a link to the package. It's under the org of Elixir dbvisor/SQL, and it's bringing a SQL sigil to Elixir. Here's a quote from the repo. It says, brings an extensible SQL parser and sigil to Elixir so you can confidently write SQL with automatic parameterized queries. So Ecto does this a bit anyway, right? But just not with a sigil. So you write your Ecto queries. There's a bunch of macros that turn that into all that we know as good SQL and safe SQL. And inside of Ecto, there's all that AST to deal with that, to turn it into SQL, like a stringified SQL, right? That actually goes over the protocol wire and lands at Postgres, for example. So this, from the looks of it, looks inspired by that AST that Ecto is producing. And the idea here is that, and now I don't know what the end goal is necessarily, if the end goal is for it to be a part of the Ecto project or not. The effect here is that you can write, for example, sigil SQL, and then your string in it, and your string in it would be from users. Okay, so there's a fragment there. And then you pipe that into another sigil SQL, and then that string has where email equals, and then you interpolate an email value in there. And then you keep on piping, and that's how you can kind of compose these things, right? And then that SQL, that sigil SQL stuff is something that can end up being sent to the deep down adapter, straight to the database at that point. Yeah, I'm sure there's a lot more work to do here. What this is doing, I believe one of the ways that they're accomplishing this is that there's a somewhat of a behavior. So in your schema, for example, you could use SQL, this new module, and then you can implement some of the callbacks that they kind of need for that stuff to work. So for example, when you use Ecto schema, it provides some reflection functions for you to know what columns are actually in the database. And so you might use that to ensure that, your interpolations, are going to be against actual columns or something that's selected, that kind of thing. It's not a high level library at all. You're not gonna just use SQL and then magically be able to sigil SQL around everything and be totally safe. At least not yet. So it'd be interesting to see where this goes. But it is a pretty nice, at least the examples looks like a pretty nice way of writing safer SQL that's compatible in Elixir and still readable and all that kind of stuff. And I think the goal is to be compatible with Ecto itself. So probably a lot more to develop there. So instead of writing Ecto queries like we are used to today with all of those macros, perhaps the goal here is that you would write a sigil SQL string, and that still works with Ecto, but it's legit, actual SQL that you're writing, but then it parameterizes it the same way that Ecto would via its macros.
Interesting. Another benefit of having a sigil SQL is that you can get the code highlighting to actually highlight it as the SQL language. And that might make it easier to have code completion, just that you could be able to bring in some other tools because maybe it's more aware of underlying schemas or something like that. So
yeah, there are database or SQL LSPs out there, so you can connect it to your localized database where it can then reflect on like the schemas, and that's how it can do the auto completion stuff for you too, which is pretty nice. Yeah. So it's experimental. I'll repeat, it's very experimental. So it's really just something that you might want to watch. So I'll be watching it. It is currently being discussed on the Ecto, the Elixir Ecto mailing list. So I'll have a link to that mailing list in case you want to just star it and watch it. I'm really kind of curious to see where this goes. I'm kind of excited too. We'll see.
And next up, a new talk landed from the GOTO 2025 Elixir conference. That's GOTO. And this one was with Saša Jurić and Adrienne Braganza-Tak. I'm sure I pronounced that incorrectly. Apologies. But their talk was about small PRs, big impact, the art of code reviews. And honestly, that's a good type of talk to have. If you watch it and you find value in it, it's the kind of thing you share with your team. Maybe help everyone improve their code reviews.
Yep. Speaks right to my heart. I just had 2 huge PRs that I feel bad about. So it's always difficult. I get it. I know. Rounding out our news, we don't have a lot of news today, but rounding out our news, we're going to talk about the upcoming conferences in the Elixir the Elixir ecosystem out there. So the first one coming up is Alchemy Conf. That's at alchemyconf.com. It's happening on March 31st through the 3rd of April, so it's right around the corner. And this is happening in Braga, Portugal, probably a very pretty place to go to right about now. Next one is Gig City Elixir and NervesConf. That's gigcityelixir.com, where you're going to find more info. NervesConf is happening on May 8th, and Gig City Elixir is happening just the day after May 9th and the 10th. That's happening in Chattanooga, Tennessee. Good old USA. That's a good regional conference that I think a lot of folks would enjoy. So if you're in that southeast region of the US, Chattanooga, Tennessee is a good, beautiful spot.
And 2 more, ElixirConf EU. That's at elixirconf.eu. It's May 15th and 16th, 2025 in Krakow, and virtual as well. And then also Goatmeyer tickets are on sale now. We have a link to that, goatmeyer.com. That's September 10th through the 12th. 2025 in Varberg, Sweden.
Lots of conferences, lots of activity. 4 conferences coming up this year, and that doesn't even include ElixirConf US, which I think is going to be happening a little bit later. So lots of activity out there in the world. You should definitely go meet up with some like-minded folks and have some fun while you're at it.
And that's it for the news. Today's Thinking Elixir show is brought to you by our friends at GigElixir, the premier development platform for Elixir and Phoenix projects. If you use the promo code THINKING during sign-up, you get 20% off the standard tier prices for an entire year. That's thinking at gigelixir.com. Or if you visit gigelixir.com/thinking to sign up today and get your 20% off your first year, we'll have links to that in the show notes. But today we are being joined by our very special guest, Jonatan Kłosko. Jonatan, welcome back to the show.
Hello, thanks for having me.
I don't know, I kind of consider you as like a superhero where you seem to be with your hands in all these different places. And maybe you have the time to do it because you stay completely off social media. Maybe that's the key. I don't know. But we're super happy to have you join us because you've been heavily involved with live books, and really the biggest thing that is new and exciting that we want to talk about was PythonX and the Fine library and what this all means really for Elixir. Where does this come from? And you seem to have been heavily involved, so thank you very much for coming on to talk with us about it. But before we get into all of that, I'd love to hear more about you. Like, where do you live and what kind of work are you doing?
So my name is Jonatan Kłosko. I'm from Poland, but currently I'm traveling, so at the moment, I am in Japan, and regarding the work, as you mentioned, I work on Livebook, and that's kind of the point around which I circulate. And related to that, the numerical Elixir. So I created Bumblebee, and I contribute to NX and all of the different projects. And all of that I do at Dashbit, where I also joined the subscription team, the Elixir development subscription, starting this year. And yeah. That's where my focus is.
Yeah, so I saw that blog post recently from Jose. It was titled Dashbit Plans for 2025 and saying they're expanding their subscription team. So it sounds like part of that expansion is you joining it. What is that like? What is it like being on the subscription team?
Yes, so starting this year, I joined it. Also, Stefan from the Phoenix team joined it. And we, together with Jose and Wojtek, are part of the team. And the way it works is that we work with clients. We provide code reviews, participate in technical discussions and meetings. And the main idea is to like unblock Elixir teams and make sure the code quality is good. And we also help in making the crucial architectural decisions. And another kind of thing that we benefit from it is that we use the subscription as a feedback mechanism based on what we see in like all of those code bases. We inform improvements to the open source projects that we maintain, and in turn this like helps the whole ecosystem to grow. And if somebody listening is like would like to consider that for their Elixir team, they can contact us at dashbit.co.
So you mentioned that you're in Japan right now, and like right now as we're recording this, it's 1 a.m. your time. So very much
bless you.
Appreciate you joining us and taking time to talk about what you've been working on. But also, and I got to catch up with you because like a long time ago, we talked about how you were heavily involved in speed cubing, which is like the Rubik's Cube solving where they have competitions. You even wrote a live view application that's used by the World Competition Organization, right? So we have a link to that in the show notes. But like, are you still involved with speed cubing, and just how do you find time for all this stuff?
There's actually a catch. The application you mentioned is called WCA Live.
Yeah.
It's not written in live view.
Oh, it's not? Okay, I totally thought it was.
Yeah. The live part comes from the fact that it's an application used during competitions. So it's like for live results, and that's where the names come from. Yeah, and actually the fun fact is that Jose was confused when he was like looking at my GitHub profile. And when I started working at Dashbit with Livebook, he thought that the application was in live view and that I had like live view experience, which was not the case. But I quickly learned as I started developing Livebook. So
I guess having live in the title of it is what's throwing everybody off. But I see now it's a typical Phoenix project. It looks like you're using GraphQL in there. You got mutations. Like okay,
yes,
still very good and still very cool. Just not exactly live view yet. Yes. That's all. Yet, and I'm saying yet because you're gonna port it, right?
Because it's got to be, you got to have the pub sub that immediately flashes up as the different competition rounds complete. I'm just adding more stuff to your to-do list, I know.
Yeah, but since you like asked about speed queuing, I was heavily involved in the like competing as well. But it's been like a few years since I kind of stopped doing that, but I still like maintain a few projects. Basically, like when I started programming, I was already involved in cubing. And naturally, like a lot of first projects that I did, like software projects, they were related to speed cubing. And so I was like developing a lot of open source tools. And I also became part of the official like World Cube Association software team. And we're developing tools as part of that. So yeah, there's like a lot of open source that I did and still maintain, even though like I'm kind of less competitive at this point, right?
That's really cool. I love it when you can take a non-technical hobby and still bring other, combine it with other interests, like bringing in your technical experience and joy, and combining those. That's awesome. All right. Well, we are happy to have you to talk about PythonX that we talked about in a previous episode, just that it was new and had come out. But really, there's a lot of questions that we still have about what this project really is, what it represents. So maybe you can just start off with giving us an overview of what is PythonX.
Sure. So PythonX is an Elixir library, and what it allows you to do is run Python code alongside your Elixir code. That's the shortest way to put it. In terms of like API, it's very simple. You can call PythonX eval, give it the Python code as a string, and you can also specify which variables should be available to that script. And that Python code is evaluated, and you get a result. The key point is that this code is evaluated in the same operating system process as Elixir itself, like in the Beam process. It doesn't create like a separate, Python process whenever you evaluate something. It all is in the same memory space, which means that like copying between Elixir and Python objects is like much faster, much cheaper. And the integration overall is like much more tight.
Interesting. I didn't realize it was all in the same memory space. And this is, I guess we'll get into it, but is this because of Fine?
Yeah, no. So Fine is like just a way to write NIFs in a streamlined way. It's basically like a more ergonomic way to do something you can already do. But we can get into that later, yes.
Another big question, I guess, around PythonX is why was it created? Why created now?
When we started the whole like Elixir, numerical Elixir effort, we explicitly didn't want to just be like a wrapper around Python. And there's like for several reasons, right? First of all, like we wanted to take a step back, look at the whole experience in like Python and other ecosystems like R, and then like build the APIs the way we want it and the way we think fits Elixir best, right? So we would like make the proper trade-offs and have like a solid foundation for people to write from machine learning to any kind of data processing workflows. But like inherently, given the how old Python is and like the amount of research and scientific packages that are available, and also like their very recent research into like machine learning that is going on, there are things that you like cannot do in Elixir directly. Like there is no, let's say, like an Elixir package that does a particular thing. And so we wanted to, at this point, also provide like a tool so that Elixir developers can access all of the things in the Python ecosystem, while also having the option to use the ones already available in Elixir and potentially like invest more into the Elixir side in the future.
Gotcha.
Again, the main idea is to like unblock the people in Elixir who want to use packages and functionalities available in Python and not readily available in Elixir.
Gotcha.
We're going to have lots more questions about the technical, how this works, but there are some other questions just organization wise. Like one in particular, I noticed that the PythonX library is under the Livebook dev organization. When I look at that, I was like, should I be thinking about this as being more closely aligned with Livebooks? Or is this something that really is still okay and totally expected to be used in a production environment with Elixir?
I would say it's both. The reason it's under Livebook is because like Livebook has been the kind of driving force to invest in PythonX, and we want to bring Python into Livebook as an embedded environment so that you can like have Elixir and Python code cells cooperating with each other, like all within the same Livebook, the same notebook. But you could still totally use it in a production app. You just need to consider a few of the like caveats related to the global interpreter lock and, you know, in general, what it means to bring Python into your application. However, one very major problem with relying on Python in your application is that you need to like manage the Python environment, all the dependencies on your own. And that's also a thing that PythonX streamlines. We have a way to just like, for you to write PyProject.toml, which kind of like mix EXS, right? But for Python, where you specify the Python version, the Python dependencies, and PythonX is going to like download it. If you use Elixir releases, it's going to put all of those files in the Elixir release. So when you deploy your application, it's like all available and handled for you.
Oh, interesting. So I know it's an interpreted language, but I still see like PyCache and C compiled stuff that happens afterwards. Is that there's essentially like this at runtime release process that kind of just, I guess, compiles as it goes. So with like Elixir and IEX, you know, it doesn't pre-compile all the things. It kind of compiles it as it needs. It lazy loads it all. And I'm guessing that's Python's norm, is that they lazy load or not lazy load. So is PythonX also managing that kind of process too? Because there's always like more files that seem to get created when I run Python projects, at least.
Just to make clear, like when you download all of the dependencies in Python, it becomes a part of the release. So for example, like .py files from all of the dependencies make it into the release. However, when you like evaluate code at runtime, that's the point where Python like would compile those modules, right?
Right.
It's not going to happen at like Elixir compile time or the release build time. It's going to happen the first time the code is evaluated.
Gotcha.
But what we do is like when you call PythonX eval and specify your Python code, it's going to be compiled once, and then the same bytecode is going to be reused on the further invocations.
But that's normal for Python projects. That's not unusual. Yeah, gotcha.
That's cool.
So PythonX is like an Elixir native like package manager too. Like Python has UV and Poetry and all these other pip and all these other. I can't even count all of the ways that Python has itself managed. But I didn't realize that PythonX was essentially rebuilding some of that kind of stuff too. But in the context of running alongside a mixed release or Elixir project, that's pretty neat.
Oh yeah, and just to be like clear, PythonX actually uses UV, which is one of the Python managers. The nice part about UV is that it's like written in Rust, so it's a single binary that you can download. And
nice.
so what we do in PythonX, we download the binary for the given architecture, right? And then we just build the PyProject toml and call UV.
Gotcha. So what's the story for folks that have like an Elixir code base and a Python code base, and they're already using UV, for example? Let's just say that they are already using UV. So, I've got a monorepo, for example, and one of those apps is an Elixir app and the other one's Python, and it's managed by UV. Is there a way for those to kind of cross collaborate inside of a livebook at this point, or does PythonX really manage the environment yet again kind of over its, on its own?
Yes, so you need to specify like the PyProject toml, but what you can do with local application is that one of the packages you can like point to the local directory, right? And then you would be able to like invoke functions from the modules from your local application. Assuming like it's more of a module library.
Yeah, so it sounds like it really is intended to say I'm accessing a library, a Python library, as opposed to like, here's an entire web service, has web entry points and stuff like that. It's not really for that.
Yeah, but on the other hand, Livebook can also be a reverse proxy for a bunch of stuff and starts its own Livebook, it can start its own live Phoenix Live View servers and stuff. Like, it's kind of ridiculous how much stuff can happen in there. Yeah. So I can totally imagine now, in a monorepo, then you already have a mature Python app, assuming it's packaged or managed by UV. You set up your Livebook like adapter here to go point to that project. And then you could you could have it start the app server over there. Let's say you're using Flask for some reason, and you're using Flask, and you tell it to start the Flask server, and then now you have, hopefully, I'm guessing, in your Livebook PythonX package pointing to another thing with a Flask server running, so you can have your Elixir code call out to that Flask server like API and start doing things, right?
One way to do it would be to expose the server startup as a function, and then you just like call that, using PythonX eval. Yeah. Probably the kind of edge use case, right?
But that seems to be what people end up playing with Livebook, right? It's like it's the strange edge case. This brings up an interesting question for me, though, is when you started this, how much prior Python experience did you have? Like, were you, have already had a lot of exposure, or is this like, I'm stepping in new to Python as well?
Yeah, so I didn't write that much Python before, but I certainly read a bunch of Python when implementing Bumblebee, because a lot of the models we were implementing as a counterpart to the Python implementations. So that's one of the recent examples where I was reading a lot of Python and reverse engineering a bunch of code. It's kind of funny that the way that Python is embedded into Elixir is actually mostly a C++ code. So, I mean, that could partially explain that it wasn't about writing that much Python anyway, more like C++.
Yeah. When I think of PythonX, right, and when I was looking at this announcement, and you also mentioned that it's in the same process space, but we have these different types, right? Elixir has its own set of types that are unique to it, like PID, but then you have, integers, and an Elixir integer isn't like it is in C, where it's very, it's a 16-bit or 18-bit or signed or unsigned. How are you managing the types going between Elixir and Python?
One of the things that PythonX provides is this tighter integration where we automatically convert Elixir data types to Python. And this is based on protocols. So we implement the encoder protocol for different Elixir types. And a lot of the built-in ones are already in PythonX. So for integer, string, binaries, lists, all of those things we already provide implementation for, which means that when you evaluate the code, you can pass an Elixir list of integers as an argument, and it's going to be automatically converted into a Python list of integers that you can use in the script. And since this is a protocol, it's also possible to sort of extend it to other libraries. So in the future, I want to implement it for some of the projects in the NX ecosystem. So you can imagine a Explorer data frame. We would implement the protocol to convert into a pandas or polars data frame on the Python side. And similarly, for NX tensors, we could convert it into NumPy arrays, right? So that's part of the story is the encoding. And then there is the other part, which is the decoding, which means if you run this Python code, right, now you have like some result. Let's say you add two numbers. You have a number, but this is a Python object. And PythonX also provides a way to decode that Python object into the corresponding Elixir one. And we have like some ideas how we could even make it more expressive with the incoming Elixir type system, but that's kind of a future discussion. I'm just leaving it there for further possibilities.
I was going to ask, but I guess we'll leave it. Yeah, protocols for like basic Elixir types then. So I know like the guards of is integer, is float, or something like that. But I know that sometimes, especially as a lot of these Python libraries really just bind over to something in C anyway, C has a bunch of different kinds of numbers. So the tensor one makes sense to me because that's already its own struct. How do we go from like just a normal number inside of Elixir to an unsigned 16-bit number versus a 32-bit number versus a 64-bit number? That's just not enough information. There's something's got to be given up here, right? Which I'm assuming, and you can tell me, but I'm assuming that we just go to the highest bit of a number just to cover our bases. But then once you get into these mathematical things, where memory makes a lot of sense here, you need to conserve it. You want your smallest amount of, bits for those numbers. Maybe this is too technical, but tell me at least how's that handled? Where's the decision point happening?
Yeah, so for the built-in times, Python actually like matches Elixir to a fair extent. So for integer, Erlang and Elixir, they have like unlimited integer, right?
Yeah.
Which is stored differently depending on the size, but at the end of the day, it's like unlimited integer. And Python also has the same idea of like long integers, right? So we can convert like basically any Elixir number into the corresponding Python number. The only kind of question is how to do it if we need to go through C, but depending on the type, we can do it differently, right? Like if it fits into 64 bits, we can use the C methods to read us 64 bits and build a Python integer using that. And if it's like way longer, then we can just like serialize it into a string, which is like not exactly the most efficient, but again, this is converting between Elixir and Python. So this is like a very marginal thing, especially like most of the time you're not going to use integer with 100 digits, right? But the point is like, if you do, it's going to work anyway.
Gotcha.
So.
Yeah. Gotcha. That's throwback to, what was it? A couple of, was it OTP 26 or 27 where Erlang implemented that Ryu string to integer, algorithm that was so much faster so who knows what Python's doing? I don't, but we would just be relying on the quickness of that kind of conversion stuff for real long numbers. Well, that's very interesting. So you're diving into, marshaling in and out, encoding and decoding all these Elixir terms in and out of Python and Elixir. There's got to be more though. So I'm thinking about OTP, I'm thinking about processes, and I'm thinking that that's like one of the big benefits of somebody, choosing Elixir and Erlang is for the OTP and the, not to use an overloaded word, but the agentic way of of managing data and all of the memory for those, processes. But when you mix in something like Python, which as I understand today, Python has, kind of this whole jungle of memory that is globally accessible. And I know that it's much more complicated than that. In Python, there's also this, because it's all globally managed there's got to be some kind of memory cleanup process, and that's commonly known as the global interpreter lock, where code execution kind of freezes while that, system cleans up all of the unused symbols at that point to free up memory so it can continue going on, as efficiently as possible. How is this handled? What would this look like, for an OTP developer? How do we handle this? Or is it anything that we have to think about at all? What is PythonX doing with this?
Yeah, so for people listening that don't know Python well, I'm just going to explain the global interpreter lock. It is exactly to fix the issues that Erlang avoids by using the process model with local memory. And the thing is that if you have for example, multiple threads that are sharing memory, right? You don't want them to modify the memory at the same time. If it was C, you could still use actual parallelism and then use mutasis for synchronization. But the way Python solves it, and it's kind of historical why that's the case, but what they do is they have this lock which makes sure that only one thread of Python code is executing at the given time, right? So you can get concurrency by, let's say, a thread waiting on a database query and another thread being given the CPU time, right? But you cannot have two threads that are like actually running at the same time and modifying the same memory. This means that it's introduced a caveat when using Elixir, because now you can imagine if you spread PythonX evols across your whole application and you have separate, which already sounds bad, right? But like, if you have separate processes and both of them are trying to evaluate Python code, only one of them is going to be running at the given time because of the global interpreter lock, which ensures only one evaluation is going on. That's why we also like mentioned in the README that if you are using it in an actual Elixir application, you should either put it in a single process so that it's like clear that that's the point of interaction. And for example, you can like batch requests to the single process, right? And do the processing in Python, but it's clear that it's like the single place. If you do it multiple processes, you need to be aware of this caveat that you may lose parallelism, right? Like you may make your application slower. There is one thing worth noting though, which is that this concern with global interpreter lock is only relevant for like just pure Python code. If you're using package like NumPy, PyTorch, or any of those like machine learning libraries, what they're actually doing is they are calling out into C++ native code. And while this happens, they usually release the global interpreter lock, so like other code can run, and they manage the concurrency underneath all on their own. So they like use multiple threads, it's all happening in parallel, and that's good. So either of the two things, you either use a library which handles the parallelism and you don't need to worry about the global interpreter lock too much, or you need to be aware that the global interpreter lock may result in your code being slower if you do multiple concurrent evols.
Yeah, okay, so just to repeat a little bit of that then, so the multiple processes running Python code, that Python code is managed on the Elixir side through a process via a NIF, and that NIF is still Python code, but that Python code is still global memory even outside of the NIF, right?
Correct.
That's the way that Python works. So even though we have multiple processes on the OTP side, it's still global on the other side of it in the Python world.
Yeah, and also if you do it like from two separate Elixir processes, if you do like PythonX evol, they can like start concurrently because Erlang is going to use separate scheduler for both of the invocations.
Yeah.
Erlang maintains like multiple scheduled threads. Yeah. So the Python evaluation would happen within two separate threads, but because of the global interpreter lock, only one of the evaluation would be like going at the given time, and the other one would be blocked until there is a point where it can proceed.
Okay, and so I'm imagining like there's another library on Hex that does a similar thing for like just running node programs. Right, and one of the things that this library is handling for you is basically a pool of processes of available node, runners, if you will. I'm assuming the same thing is happening in the node world, where there is there's global memory being shared even within that pool, of node runners, but it's only a set of node runners. Does PythonX have that concept of managing a pool of Python, evaluations going on, or is that something that the developer would have to handle?
Unfortunately, like there is a C API in Python that allows you for like starting separate interpreters, which means that theoretically you could like use them at the same time. But the problem is that many libraries in Python, for example, like NumPy, which is basically used everywhere, it doesn't really support the multi-interpreter use case. Because NumPy uses like a lot of C native code, right? So if they use some global memory, then it's going to break the multiple interpreters case.
Yeah.
Because you need to remember that it's all running in the same operating system process, right? So it's not like we are spawning
layers upon layers upon layers of like figuring out how this actually works. Yeah.
So this is really interesting because originally I was thinking, okay, because of the global interpreter lock, it would make a lot of sense to put a gen server as an access point because it serializes everything into, sequential requests and have that be the point of contact for the Python interpreter. But my thought was, I could probably run multiple copies of the interpreter if that fit my use case. So then that's like the whole pool idea. But it sounds like that may or may not work depending on what libraries in Python you're using, because NumPy says, I'm doing deeper C stuff, and I say, no, you can't do that. Is that right?
Or it's not even relevant. Yeah.
Yeah, precisely. And that's the reason like we just don't have APIs for that in PythonX, because if like a library is so prominent as NumPy doesn't support it, then and the developer like would need whether the library supports it, which is like only asking for trouble, I would say.
Yeah.
So if you like actually want multiple, like a pool, I would probably go with using Erlang distribution and just have multiple
Beam
Elixir
instances.
nodes. Yeah, and you connect each of them uses PythonX eval, and that's what I would
Interesting.
do. And to be clear, like again, it's not like that you cannot have multiple processes that use Python eval. It's just that it would be a bottleneck to do that, right?
Yeah.
You need to be aware. Like there wouldn't be a memory problems because of the GIL. Like it's going to make things work, but it's just not going to be as efficient as you would like.
Yeah, it won't be truly in parallel. Yeah.
Yeah.
Yes.
All right, and so just as a note here, because we're talking at a point in time that Python handles the global interpreter lock, as it always has in the past. It's always had this, but as of PEP 703, there are discussions and plans on removing the global interpreter lock. Now, that may not matter, as we've already discussed so far, because a lot of these Python libraries are C binded over to, managing memory differently through the C library. So this is only one piece of the puzzle. But today, the Python global interpreter lock is default, and that's going to remain the same in the short term and the long term. Since PEP 703 was accepted. But in the long term, it seems like their plan right now is that would be an obstacle removed. I don't know the technical details of how they're going to do that. It's going to be beyond me. But this whole conversation around the global interpreter lock within 5 years, as they are suggesting, within 5 years would be a moot point anyway. So we'll see how that goes. And PythonX is still chugging along, and it's not like it's handling the global interpreter lock itself. Anyway, it's just evaluating Python at that point. But how Python does it, that's going to change in 5 years or so.
I gotta say, how long did it take? And it's still, I don't even think it's done yet. Like the move to Python 3 from Python 2. It's been like a decade in the process, and it's still not there. So I don't have a huge amount of hope, I guess.
Yeah, because it's also like the matter of migrating all of the libraries that use C APIs, right, like NumPy, to, I guess, support the lack of global interpreter lock, which means you need to be more careful with the memory. But hopefully in the future that happens, and it will be like more effective by default.
But insert shrug emoji. Who knows what'll happen?
Precisely.
Well, one thing we didn't quite touch on that was in the blog post, and I think you wrote the blog post announcing this. Is that right? You're listed as the author.
Correct. Yes.
Awesome. Good job on that. I enjoyed it. I don't think we really touched on one of the ways this works is it's using a C Python underpinning. Like it's an existing library that already was in the Python community that says, hey, I am a C application that can run the Python interpreter. And that's what's being loaded into the Elixir side.
Yes, so this is actually a characteristic of Python itself. So the reference implementation of the Python language, it's called CPython, and it's implemented like all in C. And like most of that is actually kind of packaged as a C library, right? And then the Python executable is basically like an application on top of that library, just using the APIs to run the code, interact with the objects. But that library, you can also use it to like embed Python into an application. Like if you're writing a C++ GUI application, you can embed Python so that users can like write some Python to extend the application, right?
Oh, interesting.
And more specifically, like in our case, we can use that same library interface to use Python from Elixir. And then basically Elixir becomes your Python executable. It's just Elixir API.
Yeah. That's funny because Ruby is also written and implemented in C. Almost all of the actual underlying pieces of it are actually C. So, but as far as I'm aware, it's been years since I've really been paying attention. But as far as I'm aware, they don't have like it wrapped up in a nice library where you could just say, hey, I'm going to embed that in something else. That's cool.
Yeah, it's actually important because like the Python library, they also have a number of functions, like a subset of the library. They are listed as stable, which means that they should be like compatible across Python versions, which means that in PythonX, we can write like the same C++ code base, and it's going to work no matter which Python you're like actually installing. Whether it's like Python 10 or Python 3.13, it's going to just work, and we like don't need to recompile PythonX to do that, which is like pretty important. Yeah.
Now it's starting to make a little bit more sense why it might be housed and living under the livebook dev, because you're not so concerned about the global interpreter lock in a livebook because you're working with data and it's not like production parallelized, right? Like, so it makes a lot of sense. But yes, there are situations where it might still make sense to pull it in at a production environment in an Elixir application, but really, it sounds like it makes the most sense in a live book.
Yes, precisely. It's just like a way to give you another tool in the toolkit for working with data. If it's your application, like there are fine use cases, especially if your company like already uses Python. You have like a team of Python developers that develop the modules. But in Livebook, it's particularly useful because Livebook is all about like processing data and like workflow machine learning and having access to all of the rich ecosystem of Python packages and just being able to call into the package from Livebook, but then use Elixir to manage the data later. It really makes like a much richer experience in terms of like what you can do.
That makes sense. Yeah, and going back to David's example of, hey, if you have a team and you already have some Python, I could totally see you saying, we already have this Python library, or we could take the code that's in our other Python application and extract that into a library and have that be shared, so we could bring in business logic or integrations to other services or something like that, where you could bring that into your Elixir applications and leverage that. Yeah, thanks for helping me get my head around that.
Yeah, and in Livebook, we're like, we sort of started from this idea, but we're exploring. And on Livebook main or nightly, if you use the desktop app, you can already have access to like Python cells. So you can write Elixir cells and Python cells accessing the same variables. And I'm currently working on visualizing the output type. So like if you use matplotlib or any other package for creating the charts, we're going to render the charts in Livebook. If you use DataFrame, we're going to like show you a nice table. And yeah, so we plan to introduce like much more integration between the two, so that you can have a single notebook with Python and Elixir, and it all like provides you with a nice experience.
That's pretty nifty.
Yeah, I love that idea of like having a Python cell next to an Elixir cell and variables being shared. Like that.
Yeah,
that feels like magic.
It is.
Yeah, and we are going to do the same tracking as we do for Elixir. So like, if you use an Elixir variable in the Python cell and the Elixir variable changes because you reevaluate the code, then the Python cell is going to be marked as stale. You're going to reevaluate it automatically.
And one other question I had about PythonX is this idea of, you've said it's running in the same process space, the OS process space as my Elixir application, so that the variables go through much faster because it's not having to do full copies or something. It can be optimized. So that totally brings up this question of like, how concerned should I be about this other application, this other, it's an entire C application, about it crashing and bringing down my entire beam? Or would a supervisor still be able to catch a crash? What does it look like in terms of the safety?
Yes, there are kind of 2 points. When you evaluate Python code and if there is like any kind of Python error, like runtime error or some any kind of argument or a request failure, PythonX is going to detect that error, propagate it, and basically write it as an Elixir exception. Which means that you can like either catch it or you can let the process crash and make the supervisor do the usual handling as it would be the case with Elixir exceptions. In that regard, I would say like it's fine. It's same as any Elixir code you would write. The only other thing to have in mind, to keep in mind, is the point that it is a NIF, right? So, and it is going to be the same for like NX running any kind of native code, because underneath it's all NIFs. So if there's any bug in the PythonX C++ code, or if there is any bug in NumPy native code, it could cause like a segmentation fault, right? Basically, anytime there is a native code that somebody wrote and it's not like the beam itself, there is the possibility that it's going to bring your system down. But it's kind of like up to you to make the trade-offs. Because again, if you use anything like NX Explorer, it's all going to use NIFs, and you have the same concerns.
That's cool that it would surface any caught exceptions in the Python code as an Elixir exception, which you could then choose how to handle.
That's crazy sauce. But that's how you'd expect it to work in Elixir land. So it is pretty cool that you handled it that way. There's a lot at play here for PythonX. We went over a lot of we went over a lot of livebook interop, here, which is really neat. Sharing variables, and we talked about marshaling, data types back and forth, and all of that, I presume needs some sort of handling, low-level handling, between all these systems. And in your blog post, you talked about fine, right? So the title of it is, what was it? Write Python and Elixir. It's fine. So there's a pun in there. It's fine. But fine is a library that you guys are also extracting out of all of this work, which sounded a little bit familiar to me. It's familiar because we've been tracking Ziegler, we've been tracking Rustler, and these are different languages that have their own ways of binding to those languages and, getting data back into Elixir. And so you're doing an amount of that, as well here, but for, Python and C. So can you tell me a little bit about what fine is doing at a high level?
The way you write NIFs, just to kind of give the context for people listening, is that you define an Elixir function, basically with no implementation, and then you implement a function in C, which is the corresponding implementation for that function. And what that C function receives is just like a list of terms, and it also needs to return a term, right? So it does what the Elixir function does. And what Erlang provides is C APIs for you to, for example, take a term and read it as C integer, right? If it's not going to be, if you pass like a string or a list, it's going to just error, and you need to handle that error. And so what happens is that when you're implementing the NIFs in C or C++, you keep writing like all of this decoding and encoding. So if you are given an Elixir list, you need to use the Erlang APIs to like read each of the items from the list and build the corresponding C++ vector, let's say. And if you look at projects as Rustler, which you mentioned, the way you write NIFs is just writing a function with the signature using proper Rust types. So you would use like a Rust list of integers, and all of the conversion is handled for you by the Ruster metaprogramming code. And so while writing PythonX, I started like having the ideas of, how can we like reduce this amount of boilerplate necessary for dealing with all of those data conversions, right? And I ended up with fine, which is basically like an extraction of all that boilerplate in a generic way. And you can write the NIF using the signature. You use the types from C++ that you want, like a vector of integers, and all of the conversion is going to be done for you. If there is any error, it's going to be erased automatically. And yeah, that's basically it. There's like a few other very NIF-specific conveniences, but if you're interested, like those are described in the documentation.
Okay, so it sounds like Ziegler and Rustler are higher level. They're the Elixir API level. How do I work with a NIF implemented in Zig or Rust? And sounds like fine is doing that for C, right? So I imagine a lot of people...
C++ specifically.
C++.
Yes.
Okay.
Yeah, because the C++, like, C is very, like, bare bones.
Yeah.
In terms of the data types and also the syntax. And the Erlang NIF API is all written in C. So that was kind of like the reason why I took a step back. Like, we use C++. We have kind of more tools that the language provides. So can we make it more like a Rustler? And that's what fine is.
Okay. So you could have called it CPPler, and that would be very obtuse and hard to
follow. But it's fine. It's just fine instead.
Actually, the reason it's fine, most of the functions in the like Erlang NIF APIs, they are prefixed with enif, which stands for like Erlang NIF, right? Mm-hmm. And fine is just a reverse of enif.
Oh, that's clever.
That's nice. Yes.
And it's also a short name, and since you like end up typing it, it's important to be short.
Yes.
Yeah.
Anything you type a lot, yeah, you have to think about that. Well, Jonatan, thank you for staying with us till so late in your evening. Appreciate you taking the time. But yeah, PythonX and Fine are really interesting. I think Fine makes a lot more sense for me now. I was trying to figure out, where do I place this? Like, what does this encompass? And it's like, okay, yes, now it actually makes sense. And I think other people will just appreciate having a tool like that in their toolbox to say, oh, there's this other C++ library I would really like to be able to integrate with. And this just removes a lot of that boilerplate. So that's really great. You mentioned that you're now part of the Elixir development subscription team, but what else is next for you? You know, it sounds like, having pulled off PythonX, you seem to have your hand in a lot of pies. What's next? What else are you working on?
Yeah, so the immediate things are around PythonX and like integrating it into Livebook.
Okay.
Yeah, we want to provide a good experience. So like a few actionable items are like providing IntelliSense, like documentation, as we do with Elixir functions, and there are some other interesting ideas which I can like just tease that it may or may not involve distribution.
Ooh,
yeah, and
interesting.
that's about Livebook and PythonX.
I don't know if you can speak to this at all, but Jose said that in 2025, they were focusing on interoperability. Is there anything else you can hint at? Any other interoperability things on the horizon?
I believe it's going to be most likely revealed on the Elixir conf, but I don't think I'm authorized to
okay,
to
so
provide more details.
So what you've done though is teased that there may be more, and ElixirConf is where we might want to be to hear and learn about that when it's actually announced. Very cool.
That's correct.
Well, if people want to get involved with PythonX or start using it themselves, where do they go to get started in this new area?
Yes, so for PythonX, they're reading the documentation. The API is very straightforward, so it's really like about writing code in your Elixir app. We are like mostly targeting Livebook to make use of PythonX, and it's also going to like inform our decisions and if you discover any bugs. But we're definitely welcome if people start using PythonX in the applications and run into some bugs, or maybe something doesn't behave as it would in normal Python environment. Then just like open an issue. That's very appreciated to kind of make it aligned with the expected behavior. Yeah, and also check out Livebook nightly and see how Python works inside Livebook.
Well, thank you, Jonatan. I really appreciate you taking the time to talk with us and share, really in a way, celebrate what you've done and accomplished with PythonX. I remember having a coworker show me Jupyter notebooks. This is back before Livebook existed. And just seeing what he was doing with the data analysis and all these different tools that would let him create fake data that would follow bell curves and all this stuff. And I was like, wow, that's really neat. I don't have a personal need for it. I wasn't in the data analytics side, but I could see that there was a lot of value and a lot of power there. So then the idea of bringing some of that functionality that's already there in the Python community into Livebooks. And from what I've gathered, Livebooks in some ways are more reproducible than Jupyter notebooks. That's one of the big problems that people have with Jupyter notebooks is they pass them around. It's like you can't replicate it because of the way it actually is, just the architecture of it, the way it works.
Yes, correct. That's one of the main issues that Livebook wanted to solve with Elixir. And now it's going to just work. The same mechanism is going to work for the Python integration.
That's exciting. Yeah, well, thank you for all the work you've done and taking the time to talk with us. But unfortunately, that's all the time we have for today. Thank you for listening. We hope you'll join us next time on Thinking Elixir.